Hello, in this lesson, I'm going to go over how to compute the correlation coefficient R by hand and then verify it using calculator function LinReg ax plus b. So the correlation coefficient calculation formula is given by this, right here, where the numerator is summation of xi minus x bar over s of x times yi minus y bar over s of y, where the denominator just n minus 1, right? So first thing is I'm going to set up my table. So where xi is the independent variable is credit score, where yi is my dependent variable, which is corresponding interest rate. So this is a sample of 6 people here. Now, so L1 is my x, independent variable. L2 is my y, dependent variable. Where L3, I'm going to compute xi minus x bar over s of x. L4, I calculate yi minus y bar over s of y. Where in L5, I'm going to, column 5, I'm going to compute the product of 3 and 4. Well, so let me just show you how to do them in the first row. Let's show how to do find the value negative 1.431 times 1.265. Right? How to compute that too, and then get the product. So I'm going to show you the first row basically. So okay, got the first row negative 1.43. I need to use x1 minus x bar over s of x. So x1 is 545 minus x bar, which is the average of x, 651.667 over the standard deviation of x, that is 74.543, and then hit enter. Right, that's how you get that. Now, okay, very similarly, to calculate the value for y, I do the same thing, right? So the next one is yi minus y bar. I'm doing the first row, so y1 minus y bar. Y1 is 18.982 minus average of y, 11.602 over the standard deviation of y, that is 5.834. All right, that's 1.265 approximately. Now I need to calculate the product of these two. So next one is one negative 1.431 times 1.265, and that's how I get the value approximately negative 1.84 right here, right? Again, I didn't round it correctly, I think. So 1.6. So when you multiply it, let's get the value here. You do the same thing for every single number row here. And as you can tell, there's a lot of computation here, do step by step. And it's very easy to make a mistake do this way. And notice that when I multiply this way, I actually do rounding, keep 3 decimal all the time here, rounding here. But if I do a calculator, in both times, I don't have to do as much rounding, right? So let me show you now. So as a calculator, let me clear it. So first thing, I need to pull out the summary statistic for both your independent variable and dependent variable right here. So to do that, first thing is I need to enter my data in the calculator into the list. So notice that L1 is my x, independent variable. L2 is my y, which is my dependent variable. So I'm gonna obtain the summary statistic first, the mean and standard deviation. So to get that, I'm gonna stat, go to calculate. Number 2 here is 2 var stat, right? L1, x list is L1, y list is L2, that's correct. So I just need to calculate. All right, and this is how you find all your x bar and then your sample standard deviation here. So note that I picked this one because it's sample, not a population. This is a sample of 6 people's credit score with their interest rate. So that's sample of us. So we pick s of x. And to get to more information, let's go down the list. S of y, and that's how I find them. Note that sample 6, you count 6 people here. Right, that's how you find some statistic. Now let's go back to our list. So go to stat. Okay, so L1, L2 already enter the data, so we already have X and Y. Now to get to L3, which is the data right here, we're gonna use. So I'm gonna calculate that in one step, right? So I'm gonna highlight L3, and then I want xi minus x bar over s of x. Okay, so xi is in all the x value in L1, so I'm doing L1. So second one, give me L1, minus x bar is approximately, which is 651.667 over the standard deviation of x, which is 74.543, right? Enter. Right, that's how you get the value in L3. Again, I can do the same thing for the value in y, which is in L4, or column 4. Okay, same thing. I want yi minus y bar over s of y. Yi is in L2, all the y values are. So second 2 gives me L2. Y bar is 11.602. Alright, and over the standard deviation of y, which is 5.834. 5.834, enter. And that's how you get the value in column 4. Now in column 5, I just need to multiply the product, the value you get from column 3 with column 4. So for example, negative 1.431 times positive 1.265 gonna give me the value in negative 840 here. But this value here actually is more accurate than the one if you would multiply these two, because I'm not doing any rounding here. Notice that L3, L4, you can highlight, can see that I'm not rounding to 3 decimal places. There's no rounding for L3, L4 at all. It's just whatever output I get from the calculator. Right, so L5, I'm gonna do highlight L5, L3 times L4. Second 3 give me L3, right? Times second 4 gives me L4. Close parenthesis, enter. Right? That's how you get the value in L5. Again, I'm not, notice that the value has many digits here, 12 digits. I'm not approximating, so which is making it even more accurate. Right? Now I want to sum up all the value in column 5. To sum it up, I need to go to stat. I'm going to do one bar stat. Remember, I want column 5. Remember, so stat, calculate. One bar stat. I want to calculate one column. The value in L5, so second 5. All right, and the second, this is summation of x. That's the sum, which is negative 4.879. Right, so that's the summation of the whole column, and that's how I got this number over here. Right, so I pulled it out directly from the calculator. And once I've done this, I find the summation, which is my numerator, needed to calculate the compute R score. So negative 4.879 over 5. Sample size 6 minus 5. To divide that, you get approximately negative 0.976. So which is a very strong negative correlation. Okay, now I compute that, found my value by hand. I can always verify how close my computation is, how accurate I am to the actual value of R. So to find that, I'm going to use the calculator function, LinReg ax+b. So let me go to do that. So stat, calculate, and notice that number 4 is the function that we wanted. So, and now x list is where your independent variable. So it's in L1, x. And L2 is your dependent variable, which is a y list, right? So here, I just want to calculate and enter. All right, notice that the R score here, if I round it to 3 decimal places, they will be exactly the same as the value we got over here. So that means our computation is really accurate, really close to the actual value, because I actually use a calculator to assist the process. All right, thank you for watching. I'll see you next time.